TensorFlow Serving for model deployment. TensorFlow Serving is a flexible, high-performance serving system for deploying machine learning models in production environments. It simplifies the process of serving TensorFlow models over a network and provides features such as model versioning, monitoring, and scalability. Let's deep dive into deploying TensorFlow models using TensorFlow Serving. It kind of consists of 7 steps. The first step is installation and setup. Start by installing TensorFlow Serving on your server or deployment environment. You can install TensorFlow Serving via Docker or by building it from source. For that, here is an example. You can say docker pull TensorFlow/serving. The second step is exporting TensorFlow models. Before deploying a TensorFlow model with TensorFlow Serving, you need to export the trained model in the SavedModel format. This format includes the model architecture, weights, and metadata necessary for serving. So first import TensorFlow SDF, then you can call the keras.model.load model function and pass the h5 file, and then you can for using TensorFlow call the SaveModel using save function and pass the model and the saved model in there. Next step is running TensorFlow Serving. Start TensorFlow Serving with the exported saved model. Specify the model name and version as well as port to expose for serving request. This you can do by your docker run p port number 8501 dash name equal to TensorFlow Serving, mount type equal to bind, comma source, and path to the saved model. Then target is model name, and next is the model name, where using the -e parameter pass the model name, and by using the -t TensorFlow Serving. Next step is for serving request. Once TensorFlow Serving is running, you can send inference request to it using HTTP or gRPC protocols. The model name and the version are specified in the request URL or headers. Examples of sending an HTTP request for inference: here you can call the curl method -d and pass the instances 1, 2, 3, 4, pass their values, and you can post it to, let's say if you're running on your local host 8501/v1/model/model name and then predict. So this is how you can pass and get the request passed to the HTTP server. Next step is model versioning and updating. TensorFlow Serving supports model versioning, allowing you to deploy multiple versions of a model simultaneously and switch between them seamlessly. This enables alpha beta A/B testing, gradual rollouts, and model updates without downtime. Next step is monitoring and management. TensorFlow Serving provides monitoring and management capabilities through a web inference interface called as TensorBoard. You can monitor model performance, request latency, throughput, and other metrics in real time. Last step is scalability and performance. TensorFlow Serving is designed for high performance serving of machine learning models at scale. It supports serving multiple models concurrently, load balancing, and distributed deployment for handling large inference workloads efficiently. TensorFlow Serving is a powerful and scalable solution for deploying TensorFlow models in production environments. By following the steps outlined above, you can deploy trained TensorFlow models with TensorFlow serving inference requests over HTTP or gRPC protocols. With features like model versioning, monitoring, scalability, and performance optimizations, TensorFlow Serving enables robust and efficient deployment of machine learning models for real-world application. Consider incorporating TensorFlow Serving into your deployment workflow to streamline model deployment and management in production environments.